to show that we have a density function, all of the outputs of the density function, all the y values, they need to be positive. So those need to be above the x-axis, which indeed they are, if we go back and look at our graph. So the normal distribution is a mound-shaped distribution here. So it actually extends forever. The x-axis is what's called an asymptote. So the graph gets closer and closer forever and forever to the left and to the right, to the x-axis, but it doesn't ever cross it. So our y values are always positive. So that's the first condition. So we're okay there. The second condition then is to make sure the area between the function and the x-axis, it needs to be 1. Now in order to show that, we need a new command. So to verify this, we're going to turn off the histogram and we're going to set our window to a different window setting. So remember, this is going to be the standard normal distribution. So, and the standard means we're using z-scores. So we're going to graph it from z-scores starting as low as -3 and as high as +3. And we're going to use a scale of 0.5 on the x-axis. You could use a scale of 1. That would be fine too. This is a density function, so the truth is it's not going to be very tall because we want the area to be 1. So a y minimum of -0.2, a y maximum of 0.4, and a scale of 0.1 is more than sufficient to see what's going on. So turn off the histogram first, and then we will set our window, our x's and our y's. So to the calculator, second y equals, we're going to turn off our first plot. So then we're going to press the window button. So, and we need to change then to an x minimum of -3. Make sure you use the negative button, not the subtraction button. So an x maximum of +3 and a scale of 0.5 is sufficient. So a y minimum of -0.2 is perfectly sufficient. A maximum of 0.4 works, and a scale of 0.1 will be just fine. So, having set that window, now it's time to look at a new command. The name of this command is called the ShadeNorm command. And this isn't really a 9 here. What that really is an open parentheses here. So to get to this command, you have to press the second button, then the variables button. You want to go to the draw menu and you want to select the very first option and then press enter. Now, once you press enter, you're either going to get a menu like you'll see on my screen, or you'll have a command to complete. I'll show it to you both ways. So here we go. Following those, that pattern then, press the second button and then the variables button. So above the variables button, you'll see it says DISTR, that's for distributions. We want the draw menu option, so we need to press the right arrow. Here's the ShadeNorm command, it's option number 1. So we're going to press enter to select it. And if you have a menu on the screen, what this is going to ask us to specify is a lower boundary and an upper boundary. And here, because we're using z-scores, our lower boundary and upper boundary are in terms of z-scores. The lower boundary I'm going to use is -10. That represents a z-score of -10. The upper boundary we're going to use is +10. So notice I know that I'm using z-scores because this expression here, mu, represents the mean, which is 0. This is the lowercase Greek letter sigma. That represents the standard deviation. That's 1. Z-scores have a mean of 0 and a standard deviation of 1. We're going to highlight the draw command and then press enter. So if you do not have a menu like this, then you're going to have a command on your calculator that looks like this on the home screen. It will say ShadeNorm, and you'll have your open parentheses specified. So you need to do the same thing. You need to indicate a lower boundary of -10. So that's our lowest z-score we're going to worry about is -10. Then you need to press a comma. So on your calculator, the comma is right there above the 7. Then after that, you need to specify the upper boundary of +10. So the highest z-score we're going to worry about is a +10. Then you need to close the parentheses. So the close parentheses button, that's right above the 9. And then you can press enter. So pressing enter after this command is equivalent to highlighting draw and pressing enter. And you'll have to wait a second. The window is reset, and this little scrolling up here suggests that the calculator is thinking. So you're going to see the normal distribution appear, and the area that we're finding is what has been shaded. So we've gone from a low z-score of -10. We're finding all of the areas starting at a z-score as low as -10 and going up to a z-score as high as +10. And notice that the area is 1. So technically, the z-scores can go infinitely low or infinitely high, but there's no reason, there is no way to put in a lower or an upper boundary is expressed as negative or positive infinity. Those aren't numbers. That's no way we can specify that. But for practical purposes, think about what negative and +10 actually mean. So a z-score of -10 says we're looking at a president's age that's so low that it's 10 standard deviations below the mean. A standard deviation is 6.6 years. 10 of those is 66 years. The mean is 55. 66 years below 55 would give you a negative age. For practical purposes, there's really no reason to put in a z-score any lower than -10 because -10 itself is impossible. Same thing on the positive side. +10 as a z-score, +10 standard deviations above the mean. 10 standard deviations is 10 times 6.6. That's 66 years above the mean of 55. Again, that's a president's age at inauguration that's well over 100. Again, that's just not going to happen. So the reason using a lower and upper boundary of negative and +10 is sufficient is because these are more than extreme enough to capture everything we need under this density function for practical purposes. These are extreme enough. These z-scores are extreme enough to account for as much of the density function as we really need for practical purposes. To account for as much of the density function as we practically need. Now, it's important that the distribution continue, that it trail off to the left and trail off to the right, because you can have really low z-scores. You need to allow for outliers on both sides, but at -10 and +10, those z-scores are so extreme, so many standard deviations away from the mean that for practical purposes, they're just not going to happen. So what we have here, we are on the drawing screen, and before you do any more with this command, you have to learn how to clear the drawing. So the sequence to do this command, from the home screen, you need to press the second button and then the program button. You need to highlight the clear draw command, and then you need to press enter twice in order to clear the drawing. So let's do that sequence. You do need to do this from the home screen. So I'm going to press second mode to take myself to the home screen. So we're going to press the second button and then the program button. That accesses the drawing menu. So notice clear draw is highlighted. So I just need to press enter once to bring the command to the home screen and enter a second time to execute the command. Now the drawing screen is clear and we're ready to proceed. So the ShadeNorm command can be used to find the area under the normal density function between any two z-scores. But because this is a density function, the areas correspond to the percentage. To the percentage of the data in a normally distributed data set between the two given z-scores. So what I want you to do is to find the area, or the percentage of normally distributed data between the pairs of z-scores that are given below in options A, B, C, and D. I want you to use the ShadeNorm command to do this, but you need to remember that after you use the command, you have to go back to the home screen and clear the drawing, just like we did in number 11 above before you can use the ShadeNorm command a second time. So let me do part A with you. I want you to find the area or the percentage of normally distributed data between z-scores of 0 and 1. So we already cleared the drawing. So we want to get to the ShadeNorm command. That's the second button. Then the vars button. That gives us our distributions options. Press the right arrow to highlight draw. Here is the ShadeNorm command. That's the one I want. Press enter. Now I'm interested in the area or the percentage of normally distributed data between 0 and 1. So you want to enter these in numeric order. So this is our lower boundary and this is our upper boundary. So lower and the upper boundary. So I'm going to put those in as 0 and 1 if you have the menu. The lower boundary of 0 for my z-score, the upper boundary of 1. Don't change these. These are the mean and the standard deviation. And since we're working with z-scores, a mean of 0 and a standard deviation of 1, those are perfectly acceptable. Those are the ones we need. Highlight, draw, and press enter. Now, if that is not how your calculator is done, you'll have the ShadeNorm command on the screen. You'll see your open set of parentheses. So you need to type a 0 for your lower boundary, and then a comma, and then a 1 for your upper boundary, and then you want to close your parentheses. So again, type in the 0. The comma is above the 7. Type in the 1. Close your parentheses. That's above the 9. And then you'll be ready to press enter as well in order to execute this command on the home screen. Either way you do it, whether you've highlighted draw and pressed enter or put in the command and pressed enter, we cleared the drawing, so the old drawing is gone. We're going to see the normal distribution again appear on the screen, but the shaded part now will only begin at 0. That's where it will start, and will stop at 1. Remember that I put in tick marks of half of a unit, so each one of these tick marks down here represent a z-score of 0.5. Here's negative 0.5, negative 1, negative 1.5. So this represents the area between a z-score of 0 and 1. That area is 0.341. So that says that 34.1% of observations in a normally distributed data set will have z-scores between 0 and positive 1. That's 0.341. So I'll approximate that as 0.341, or if you wanted to, you could write it as 34.1%. That would be fine. So before you then do B, C, and D, you do need to clear the drawing. So right now we're in the drawing screen. Press second mode to go back to the home screen. Then to clear the drawing, this sequence is listed. This sequence is listed in number 10. This sequence is listed in number 11 on your handout. So you have to press the second button, the program button, make sure clear draw is highlighted, and then press enter twice. Once to bring it to the home screen, once to execute the command, and now you're ready to do part B. You'll want to do the same things for C and for D. Bring those answers back to class tomorrow, and then we'll take a look at building what's called the empirical rule.